In this video, we're going to talk about how to answer a compound interest question that is asking about lengths of time. We're going to need to use logarithms. Sometimes we want to determine the length of time in a compound interest question. When this happens, we use logarithms. So, for instance, how long does it take for an investment of $500 to increase in value to $862.34 at an interest rate of 4.2% per annum compounded monthly? Well, in this particular question, we're told that A is equal to 862.34. That's the final amount. We're told that P is equal to 500. That's the principal. We know that our annual interest rate is 0.042, but we'll divide it by 12 since we're compounding monthly. And we don't know what n equals. So we'll say that 862 is equal to 862.34 equals 500 times 1.0035 to the exponent n. Okay, well, what we're going to do, we have to isolate n. So first thing we're going to do is divide both sides by 500. And we'll have 862.34 over 500 equaling 1.0035 to the exponent n. That'll mean that n is equal to the log base 1.0035 of the number 862.34 over 500. Okay, so we can evaluate that by either using a fancy calculator with a multiple bases to its logarithm, or if we don't have such a fancy calculator but just a regular scientific calculator, we can say n is equal to the log of 862.34 over 500 divided by the log of 1.0035. Either way we do it, rounding to the nearest integer, we see that n is roughly equal to 156. Now, occasionally a student will think, well, that means that 156 years is the required time, but not exactly, because remember, when doing a monthly question, n is equal to the number of years times 12. Well, that means dividing both sides by 12, that n over 12 is the number of years. 156 over 12 is 13, so that would mean that it would take approximately 13 years for that investment to increase to 862.34 in the conditions given.